Coulomb's law for electrostatic force between two point charges and Newton's law for gravitational force between two stationary point masses. Both have inverse square dependence on the distance between the charges and masses respectively. First, compare the strength of these forces by determining the ratio of their magnitudes for an electron and a proton and for two protons. Estimate the accelerations of electrons and protons due to the electrical force of their mutual attraction when they are at 1 angstrom distance apart. Solution. The electric force between an electron and a proton at a distance r apart is Fe equals to minus 1 upon 4 pi epsilon naught E square by r square, where the negative sign indicates that the force is attractive. The gravitational force, which is always attractive, is Fg equals to minus g mp into me upon r square, where mp and me are the masses of a proton and an electron respectively. Fe upon Fg, that is the ratio of the electrostatic force to the gravitational force, is 2.4 into 10 raised to the power 39. That is too much. Second, on similar lines, the ratio of the magnitudes of electric force to the gravitational force between two protons at a distance r apart is 1.3 into 10 raised to the power 36. However, it may be mentioned here that the signs of the two forces are different. For two protons, the gravitational force is attractive in nature and the Coulomb force is repulsive. The actual values of these two forces between two protons inside the nucleus are 230 newtons, whereas for gravitational forces it is 1.9 into 10 raised to the power minus 34 newton. The ratio of the two forces shows that electrical forces are enormously stronger than the gravitational forces. B part. The electrical force F exerted by a proton on an electron is same in magnitude to the force exerted by an electron on a proton. However, the masses of an electron and a proton are different. Thus, the magnitude of force is 2.3 into 10 raised to the power minus 8 Newton. Using Newton's second law of motion, F equals to ma, the acceleration that an electron will undergo is 2.5 into 10 raised to the power 22 meter per second square. Comparing this with the value of acceleration due to gravity, we can conclude that the effect of gravitational field is negligible on the motion of electron and it undergoes very large accelerations under the action of Coulomb force due to a proton. The value of acceleration of the proton is 1.4 into 10 raised to the power 19 meter per second square.